Great. All right. Well, I guess we can get started. Thank you, everyone, for joining. My name is Kevin Jones, Developer Relations Engineer, working at EdgeNode, working on the graph. And I'm really excited today because we have a guest, Phala Network, who's going to be talking about how to bring the graph on chain to any EVM chain with a Phat contract, which I'm really excited to have you guys see this. It's really cool. I've already seen the demo, and I'm really excited for Joshua. Joshua, thank you so much for coming on. Just as a awareness for everyone, this is going to be recorded and this will actually be posted on YouTube. So just kind of keep that in mind. But yeah, without further ado, I'd like to welcome Joshua to come on and explain about the Phala Network. Thank you, Joshua.
Awesome. Yeah, thank you for having me. Like the introduction said, my name is Joshua. I'm the Director of Tech Evangelism at Phala Network. And today I'm going to show you how we are able to bring the graph on-chain to any EVM chain of your choosing with the Phat contract that we have developed as a product. So just to go forward, you can scan this QR code right here. This QR code is actually a direct link to the docs about the graph starter kit that I built. And I documented how to test it locally, how to deploy it to a test net, and then also how to deploy it to a mainnet for an EVM chain. And in this case, I use Polygon's Mumbai testnet and then also the Polygon mainnet. So I'll just leave this up for just a little bit, just so I don't kind of rush through these slides.
I'll throw it in the chat for you as well, too.
Thank you. And also, if you have any questions about our architecture, or you want to get into the nitty-gritty details of Phala Network in general, then go ahead and join our Discord. Come and connect to our devs. We have the Phat contract channel and compute channel just to answer any questions that you may have, and we can have our core engineers answer any of these really difficult questions that you may be thinking of. This talk today and workshop won't really go into those details, but if you're very curious, go ahead and scan the QR code and then join our Discord, and we'll be happy to answer any of these questions for you. So what to expect for today? So what I'll do is give a very brief and quick overview of Phala's Phat contract. And next, then I will go into a very quick demo of a local deployment of a little trust score dApp that I built with using Scaffold-ETH 2. And then with the Phat contract running locally, I'm able to connect to some public subgraphs from the graph. And I'm able to get this information in and compute a trust score and then send it back to the smart contract deployed on the Scaffold-ETH front end. And we'll be able to visualize in the Block Explorer requesting for that score, and then the Phat contract answering with the computed trust score on chain to kind of visualize what's going on. Next, then I will kind of dive into the deployment process to an EVM testnet. In this case, I'll show you a deployed Phat contract on and the consumer smart contract on the Polygon Mumbai testnet, and I'll show you how I'm actively able to interact with it and request for different accounts trust scores. And then I'll also show you how easy it is to also update your Phat contract and then be able to compute a different score, and how easy this is just running locally. And this will be really quick and very interesting to see. After that, I'll wrap up on some potential ideas and then some other dApps that I've recently built using different subgraphs to get information and show you the potential that you could potentially build. And then also we will field some questions from the audience. And then also Zoe will come in and talk about our builders program as well. And I think Zoe's in the audience as well. So if you see Zoe, say hi.
Hello, everyone. Great to be here.
So skills required for today. Believe it or not, you're probably already familiar with EVM's smart contract development and Solidity. You're probably already familiar with the graph. So all you really need to have as a skill to be able to build your own Phat contract is knowledge in JavaScript, TypeScript, and having a can-do attitude, because it's very easy to do. I'll kind of walk through the code a little bit as well, and then I'll also show you the consumer contract code and our what we call the Phat roll-up anchor contract that you will be importing into your consumer contract, so that this connection between the Phat contract on Phala Network deployed can pull and interact with your consumer contract on your EVM chain. So what is Phat contract in general? So Phat contract is a off-chain program that allows you to connect your smart contracts to the off-chain world. So in this case, we're able to, with our off-chain computation model with Phala Network, we're able to enable you to deploy these Phat contracts to make HTTP requests from the Phat contract and be able to interact with different APIs. So in this case, we'll be interacting with the subgraph APIs that are publicly available on the graph. And I'll show you how I'll show in the code as well of what the syntax you'll need to write to be able to make these HTTP requests. And then I'll show also where you'll be computing, in this case, a trust score that will then be able to connect your subgraph from the graph to the on-chain world. And this made possible through Phat contracts in this case. So what is the code that that makes this possible? So here you can see on this left side, the smart contract side, your Solidity code is as simple as pushing a message and then encoding the ABI of the variables. In this case, this simple example is XYZ. And on the Phat contract side, which is written in TypeScript, you're able to use native VM here, and you're able to then decode this ABI encoded from the push message of the consumer contract. And whenever that is read in through this main function, the request is then decoded here, and we're able to get the variables from the encoded request that's been pushed from the consumer contract on the Solidity side. And then we're able to decode that and then handle that logic and then make these batch HTTP requests to the subgraphs, then be able to compute on that data and encode the answer that we want to provide back, in this case, the A and B. And then your consumer contract side, there's a function called onMessageReceived. And that's where you're able to decode and then handle the answer that has been brought back to the on-chain consumer contract from the Phat contract program that's running on Phala Network. So this is kind of just like a very simple layout of the communication flow from consumer contract for requesting some data off-chain, the Phat contract, taking that information, going to the graph, computing on that logic, encoding that reply, and then sending it back to your consumer contract on this side. Now, I want to stop here just to see if anybody may be confused or has a question in the moment. If anybody would like to ask a question, feel free to raise your hand and I can answer that. But if not, I will then move forward and start the first demo that we have set up.
Oh no, I just joined. I don't know what's going on. That's my question. Sorry.
Oh, it's okay. No worries. So today what I'm going to show you is how Phala Network can deploy an off-chain program in this case to be able to communicate with your consumer contract on your EVM chain and be able to also make requests to your subgraph APIs. In this case, from the graph, and this part, I will be querying like a few different subgraphs through the batch HTTP request, and then I will compute a score that is about a certain target address. And whenever I get that score computed, I will then encode the reply and then send it back to the smart contract on chain.
Cool, thank you.
Cool. So this is just like the basic ideas. We're making Web3 indexers smarter, in this case, through Phat contracts. So here is just like a overall diagram of what I'm showing. So in this basic case, Alice will be requesting a risk score for Eve. So through that, the consumer contract on the EVM chain, Alice will request that will add this new request to the request queue that will be added here. And the Phat contract that is deployed on Phala Network, it will be constantly polling to see if this consumer contract on this EVM chain has any new actions that need to be fulfilled. Whenever it sees it, it will pop that request action off the queue and handle the request. And in this case, this is where the Phat contract shows off its magic, where we're able to make this batch HTTP request from the program deployed on Phala Network. And we're able to query the EIP 721 subgraph that asks to get information to see if Eve has ERC 721 NFT. So if Eve owns an NFT, we'll be able to detect how many they have. Does Eve have a nouns DAO NFT? And then next we'll query the ENS subgraph to see if Eve has any ENS domains. And also we'll check Snapshot to see if Eve has any accounts delegating their votes to Eve on Snapshot. And this is just a custom, unique scenario where this is this program that you deployed on Phala Network would be very specific to a certain scenario. But this is also modifiable so that you can tailor it to your own needs. But in this case, I create a little scoring criteria where 1 point per NFT that Eve owns, with a max of 50 points that Eve can gain from this, has a nouns DAO NFT. So I put 69 points for owning at least one nouns DAO NFT. Has a ENS domain. I put 4 points per ENS domain that Eve owns. And then accounts delegated votes to Eve. If at least one account delegates their vote to Eve, then that gets additional 20 points to Eve. And then once that score is generated, then that information will be then sent back on chain to the consumer contract. And then in the consumer contract, you can see in storage, Eve would be associated to a number here. And in this case, it's 135 in this example, but this is just a basic overview of what I'll be showing. Some other different scenarios that I can go over later of like how you would utilize maybe this is if the address that you're requesting a trust score from, then and if that score was greater than X, then you can be trusted to transact with that user and use it more of like a spam filter in this case on chain. Another one could be if you wanted to do something a little different and interact with the nouns DAO subgraph, and you wanted to see what the latest bid was. So if that latest bid was less than Y, then you would auto bid based on the I put Y here, but oops, gotta go back. the current bid times 0.02% on the current auction, so that you can auto bid whenever you're comfortable bidding when it comes to having like an auto bidder from the Phat contract side. So now I'm gonna start the demo and go into, see if I can here. Okay, awesome. So here I have my repo here, but let me pull it up on GitHub so that you can check it out. So if you go to this link here, I can drop it in the stage chat. Thanks. This is the code repo that I am running this like local demo from. I put a quick start in here that if you follow along through this quick start, then you could easily deploy the exact same Scaffold-ETH 2 repo with the front end and be able to also like have this running live for you as you follow along. So what I'll do first is I'll just go through the exact same commands, which yarn install, yarn chain, yarn deploy, yarn start, and then I will build the Phat contract script. I'll show you where the script is, and then I will do a yarn Phat watch, which will locally watch for any new requests from the deployed smart contract on your local deployment. Okay, so here, just reinstall here. So this is in this case, I'll just like kind of pause and say this is the contract that imports the Phat rollup anchor contract that will be deployed locally on the local chain that I spin up. And then down in the Phat folder under packages, this index.ts file is the TypeScript file that is the Phat contract code that queries the subgraph and then computes the trust score here in this function with some different weight values, like I described earlier in the diagram about the point total is based on each query that is being checked based on the results from the subgraphs. So next I will start the chain. So yarn chain. All right, nice. So chains started. Next I'll deploy. So yarn deploy. All right, very nice. And then I'll start the front end. So I kind of customized it to follow those colors and called it Phat Scaffold-ETH here. I'll fund this account. I'm also using Foundry in this the Foundry version of Scaffold-ETH in this demo. And you can see this is the simple front end where I'll just type in an address and then request a trust score. But first, I need to build my Phat contract. So I'll go into another panel here, terminal here, and do yarn Phat build. And this will build this TypeScript file, and that will be the result here, dist index.js, so the JavaScript file here. And then I'll do yarn Phat watch. And now locally, this Phat contract will be watching. So you can quickly test and kind of debug if your Phat contract is right before you even deploy to testnet and have to do the testing there. So this can really speed up your development workflow as you need. So I'll go back to the front end here, and I'll just type in my ENS domain here so I can get my address, have my little dog Mojo, and I'll request a trust score. So this transaction completed successfully, and I got a return score of 16. So I can look back here and I can see that I made this request here, and that was the requesting for the trust score. And then this rollup U256 condition equals, this is the answer from the Phat contract. Now, this doesn't provide too much information here, right? Because all this is encoded. But whenever we go back here, you can enable logs to be printed in your Phat contract so that you can kind of debug and see what's going on. So as you can see here in these logs, I don't know if it's too small to see. Let's see if I can. Nope. So what you can see here is like we're handling requests. So this is earlier when I showed the ABI.encode. This is encoding the request ID, which this is the first request ID, and then I'm putting in the log. So if I go down in this main function here, you can see I'm handle request, and then I put another console log here whenever I'm decoding the request with the request ID and then the target address. And in this case, 1, and then this is my target address. So then I have a request received for this profile, and from there we go down and we can see that I want to fetch the API stats. So from there we go to this function where we are fetching this API information. The first query, like I had mentioned in the diagram, is what NFTs do I own that are ERC 721 tokens? You can see I had a few here listed, and this resulted in a number of 4. So I got 4 NFTs from different contracts, and that ended up creating like the first initial count of 4. It checked then if I had a nouns DAO NFT. Unfortunately, I don't. So that was 0. So I didn't increase my score at all. And then next, how many ENS domains do I have? I had ended up having 4. And since there is a multiplier that then increase, well, I actually have 1, 2. I have 2. Yeah, I only have 2. Sorry. I had 2 ENS domains, and that with the multiplier increased it to 16 here. Then it checked snapshot if I had any delegated votes to my account. I do not, so that didn't increase my score at all. So then it returned with this value 16 on chain. So let's try a different account now. So we can go in here and we can put Vitalik.eth and request this trust score to see like what this trust score could end up being. This might have more information. And so with their history, they have a score of 210. So that's a lot more than mine. And we can see in the block explorer the exact same process of the request and then a response locally from the Phat contract going in, and then all the encoded data here. And then we can go back and also see this same input, but they have obviously a lot more data on chain from subgraph than I do, and that resulted in a higher score. So you can interpret however you want, or you could even change the script and rebuild it, and it can also compute a completely different score. But this is a very simple way to locally test before you're ready to deploy to a testnet. And this is just like the simple basic example, but what I'm showing here is we're making it possible to now have your subgraphs connected on chain. So you can not only think of it from the trust score perspective, but you can think of it from any kind of perspective. Like even say that there's like a staking DApp that you have based on some subgraph that you have indexing on the staking numbers from your users, and based on the amount that the users are staking, this is generating some kind of yield and creating a bunch of rewards that are the result of that. So say that you wanted to reward those that are helping you stake and earn rewards for the DApp in this case. So potentially you could auction off a percentage of that as a lottery to the stakers, but you wanted to like weight it in the fashion that the more you stake, potentially the higher odds you get to winning the raffle of a percentage every month of the staking rewards. And you can actually do this, and this is like a DApp that I had built just recently to do this, utilizing another feature of Phat contract, which is VRF, and being able to generate a random number and be able to select a winner based on my Phat contract code in this case. But there's plenty of other ideas as well, but I just wanted to kind of put that out there, and just this is the basic local demo. But are there any questions currently right now that anybody has for us to answer here?
Very cool demo. Anyone who has questions, you can pop them in the chat, or feel free to come off mute to ask any question.
I have a question. I don't know, maybe I was not paying attention, but like one thing is with creating the graph network is that you need to have an API key to create a graph network, and that needs to be hidden somehow. You know, you could publish it, but so how did that work? Maybe I did not pay attention when you showed it. Sorry.
Oh, yes, this is a great question. Since I kind of glossed over this part, but in this main function in the Phat contract, we have this parameter called secrets. So whenever I go into the next part of the workshop, I'll show you where you're setting your secrets. So whenever you're setting these secrets, since all this code is actually being executed in a trusted execution environment via like Intel SGX workers that are these off-chain workers, we're able to preserve the privacy of these API keys in this case, and any other information that you want to pass in through this secrets parameter here. And whenever you decode the secrets, or parse the secrets in this case, this is one, they're passed in encrypted, and then two, none of these secrets will be revealed, since they are only they only exist within the trusted execution environment, which is running your Phat contract in this case. So here, in this case, I pass in my secrets, which are, let me go to the documentation real quick to point to these. So in this case, I pass in my secrets are the API URL here, which is just the basic gateway, the graph.com's API / and then my API key here, which is the basic API key with very limited amounts of free queries left to query the public graph or subgraph APIs. But there's also a section here that is linked in the docs that kind of goes over what the secrets are. And in this case, you can also make the secrets a little more complicated if you want to pass more secrets into your Phat contract. And this, there's also the option where you could potentially deploy a separate Phat contract that stores other secrets that potentially could like roll your keys in this case, and you could query that Phat contract from the Phat contract script that you deploy as well. There's multiple ways you can do it, but I don't want to confuse anybody by going too deep into that. Does that make sense from your question perspective?
Yes, thank you so much for elaborating this. And actually, I'm very impressed of how this is handled. It's very cool.
Thank you. So next I'm going to show like a deployed contract already that I deployed on Polygon Mumbai. I'll go to the separate repo that we have. So the template that we've developed and what's the docs that I just showed as well. This is the official the graph Phat contract template. You can also find that. You can also find that here. Under the Phala Network repo, Phat contract. Oop, that's a different one. Let me. Here we go. This is the appropriate one. Here, the graph Phat contract under Phala Network GitHub. This is the official target for this example that I showed, but this is very, very bare bones, so that you can easily customize it however you want whenever you're working with this. But this is the code repo that I'll be interacting with to show you how to show this working live from a deployed Phat contract on our POC 6 testnet, and then making a request to the Polygon Mumbai consumer contract that I deployed, and seeing that action reply from the Phat contract through our Phat-Bricks UI. So first I'll show you the deployed contract that I did previously, and I've made some requests already. But typically in your block explorer, you'll see the same thing that I showed in the Scaffold-ETH, where we had the block explorer, the requests, and the rollup transaction. So here, very similar requests, and then the meta transaction rollup transaction here. So I'll make a new request now just to show it live. I'll do a test push request. So there's a few functions in here. In this case, this is under the Mumbai folder in scripts, push requests. And this line on line 16, this is the contract, or this is the target address that I'm requesting a score from. So if we go back and also I hadn't introduced this yet, but this is the Phat contract, like a template repo that for each user who creates a Phat contract profile, they'll have something, they'll come to something like this. So I'll sign into mine here quick. And the deployed Phat contract that I have deployed is Phat contract 6. So I'll click in here, and you can see that I have a profile where I can connect my Phat contract that's been deployed to like a gas account. So this gas account I've already funded with like 0.3 Matic. I've staked behind this this contract as well, so that my Phat contract is active in this cluster. And then I, based on how much I've staked, I also get a share of the overall computation that this cluster offers, which is 3.1843% of the overall compute available to me. And then I can go into configuration, and I have my attester address, which is also the address here to be able to verify that the reply from the Phat contract to the consumer contract on the EVM chain is valid. So nobody can just send in a reply and then it can be accepted as a valid reply. So in this case, this is something also very unique about Phala Network and the Phat contracts, is that we can derive ECDSA keys within the Phat contract, so that we can derive this key pair and be able to sign and attest on our action replies to the consumer contract on chain. So this is a very unique thing here, and it allows us to be able to make this possible in a verifiable way. We also have this area here, which is the client part. So this is the EVM contract on Polygon. Here, as you can see, this address is the same here, and this is the RPC node that we define. And I added mine from Alchemy here, but you can also run your own or choose whichever RPC service that you use. And when I was talking about secrets earlier, this is where I set my secrets here. And then based on how your script is written, and you can interpret your secrets and handle them however you would like in the main function whenever you pass in this, whenever you're parsing on the secrets information from your information set here. Another thing is how easy it is to update your contract. So in this case, you can update your so under your source folder here, index, you can make a minor update, like maybe I want to change this from 69 to 6, right? And then I want to update my Phat contract, then I can do that here. So I'll take a copy here. I think this should work. Yeah, I could do that here by copying, going here, Oops. In this case, I import my I skip over this step because it can take a long time. But in the documentation, I explain what this means with the -a /Polkadot account.json. This is exporting your account so that you can enter your passphrase instead of having to enter your mnemonic key in the case that was what was required before. So I'll do that here. So you can see that where the first step where it said compiled successfully, that's where it was building the contract first, the Phat contract first, and then it was connecting to the POC6 testnet, getting my Bricks profile contract ID, and then updating the workflow 6. In this case, it's now been updated. But since we can compare now, because previously I showed like a new request and see we had a reply here from the contract. We go into the logs and we saw that this target address that we requested for got a score of 70. So maybe based on the change that I made, this score could deviate. It may or may not. Maybe we could also update a few other weights to see to make sure that it could be a lot different. So let's try that so that it could deviate a lot more for sure. Let's put 1 here and then run it again. And this is how easy it is to just update your script. It's very, very, very easy, very quick. And you can also, if you were wanting to be sure that you and you get the appropriate, you didn't mess up anything or the score didn't get off, you can easily test that through the local testnet so that you don't have to continuously pay the gas fees of updating your Phat contract in this case. But now I'm going to push a new request to see what the difference would be in this case. So I've pushed a new request. And now that should be coming in here pretty soon to the consumer contract. And whenever that does come in, we'll be able to then see if this update has taken effect already. But a really cool thing is you can also track the logs to see here if there's any other like any other changes updating live for you. So you're able to also see the logs that you've printed in your Phat contract to see if anything interesting ends up popping up here whenever you make your updates, so that you can also debug whenever you make any changes in this case. So it seems that the request hasn't quite yet got there yet. So let's see. Okay, we got our request and we should be here pretty soon seeing, yeah. So now we're seeing, we're getting this information and awesome. Yeah. So you can see that it has gone down to 55 in this case. So we should be seeing a reply here pretty soon. Yeah. So 14 seconds ago, we got a reply. We can check the logs, and now it's gone down from the previous of 70 to 55 for the same address. And that was done relatively quickly just to be able to change your trust score in case that maybe there was something you wanted to change. But are there any questions on this piece of the little test that I just showed?
So
Cool. Yeah, and there's plenty more that you can do there. You could even make your, like, for instance, you could just have the contract request for like a random number, and then have that contract connect to another consumer contract that's also requesting for that random number from the consumer contract, and then being able to then use that random number to do some other computations such that you can use that whenever you're handling the different subgraph endpoints that you're interacting with as well. I believe that so that in general is just the basic overview. The documentation, though, if you have any questions as you go through it in the where is it here in the documentation, it's pretty thorough. I wrote it just recently, and it's step by step. See if we it starts with the quick start to get you started running locally, and then goes into the information, then all the information you need. So whenever I was talking about the Polkadot account, in this case, this is what I was talking about, and I showed the two different options. There's soon we'll have the official way to use EIP 712 so that you can use MetaMask, and I'll update the documentation in here to show that, so that it'll be even easier for you to get started. And we also have a faucet so that you can have that generated Polkadot account get funded with funds as well. Now our goal in general is to simplify the user experience for you all, so that you can build these robust applications and start to really get creative, since you'll now have the power of using all of the graphs, subgraphs, and being able to then create whatever you want and have it all decentralized and on-chain for you. So we're connecting the off-chain world and the on-chain world in a seamless way, so that you can start building some real user applications and start really innovating from this point. But I also put here the local steps of testing locally, the testnet steps here with some minimum requirements that you can check off, and then the mainnet approach as well. And all of these are live contracts, so you can also see them on Polygon Scan or Mumbai Polygon, or on Polygon Mumbai as well. Let's see. Let's go back here. Here, yeah, demoed. And then I'm gonna hand it off to Zoe for her to kind of give you an intro to our Phala Builders program. And after that, we'll start fielding some questions and see what else you all have. Thank you very much.
Cool. Thank you so much, Josh. It was a great walkthrough. Hello, guys. I'm also on screen now. I just wanted to give you a quick intro of the Phala Builders program, which is a program that we actually launched last year. And it's there to support all the builders that want to start to build on Phala Network. I think the name says it all. But here, a quick overview of what kind of teams we have funded in the last 11 months, actually. So overall, we put a budget aside of $1 million in Phat token. So it will be supported in our own token. And we do want to sponsor a lot of teams that are interested in building on Phala Network, but mainly using the Phat contract technology, right? There are different tracks that you can apply. So mainly for if you bring innovation to Phat contract itself, or you have a cool dApp that actually uses Phat contract, similar use cases that Josh just showcased today. And here are just some examples, some of the teams that we funded in the last year. You see that we are also very flexible on what kind of areas these teams are building in. For example, Privadex, the team, they built the DEX aggregator. So for the DeFi space, we have a new team that is actually still built ZK adopt or ZK ceremony dApp on Phala Network. So it's very cool to see that we have here the trusted execution environments, the TE technology, that is the underlying technology on our computation cloud that actually can also host kind of different ZK applications. Or the Lucky team that was very active in building infra tooling using Phat contract. And they actually also built the Graph API Oracle. So something that you can find on our GitHub side. So check this out. And lastly, just to mention these tickets that we give, or the funding size is up to 50K in USD or 50K USD in our token. So you find all the information in the documentation also. I think Josh, or maybe I can share it in a second. And would love to see some applications, or maybe also Kevin, Simon, we will start a campaign to join the Graph and Phala maybe builders programs in the next year. Let's see, all small hackathon. But just wanted to inform all of you that there's funding available, and we always see like to see a lot of developer activity. Thanks, guys.
Thank you so much, guys. That was really awesome. Joshua, that was a really cool walkthrough and demo, a couple demos. That was really great. And Zoe, thank you for explaining that. That sounds like an exciting program. We'd love to work with you on that. So we'll talk offline. Does anyone have any more questions about Phala Network or about any of the stuff that we just walked through? Feel free to pop them in the chat or come off mute. Awesome. Well, silence is golden. That means you did a good job on your demo and explained everything really well. So, yeah, thank you guys again. I really appreciate Phala Network coming on, and appreciate all of the viewers here. As always, we meet every week, Thursday, 9 a.m. So be sure to come back next week. We're going to have Brian Knows AI, which is a hackathon project that does an AI integration with the Graph, which is pretty cool. So be sure to come back next Thursday, and we'll be around for about 7 more minutes just for regular office hours. So if anyone wants to just hang out and talk or ask questions, just hang out and have fun. Thank you, guys.
Thank you.
Thank you. See you soon.